Okay, well, I was unjustly struck down by my video recording app. So, just to recap, we're looking at the arctangent of 2x to the fourth. We've identified our outside function as arctan, or the inverse tangent, and our inside function is 2x to the fourth. We went ahead and applied the arctan derivative rule, 1 over 1 plus x squared, or the input squared, our input here being g of x. We followed that back through when we substituted back in our g of x, the 2x to the fourth, and we ended up with 1 over 1 plus 4x to the eighth. We've just done our derivative of the inside, 8x to the third, all right, and we're now at the step where we're ready to find our overall derivative by multiplying the derivative of the outside with the inside remaining the same, times the derivative of the inside function. So I've got 1 over, or 1 divided by 1 plus 4x to the eighth times 8x cubed. So we've got 8x cubed over 1 plus 4x to the eighth. And that's our derivative. So we're going to boot scoot on down and go ahead and do the next one. All right, so this one's going to be a little bit of a pain in the tuchus, not going to lie to you, all right, because we've got three things happening here. We've got our innermost function, that 5x squared. Then we've got an outside function for that, the arcsine, and then we've got another function, that cubed, on the outside. So we've got like three pieces. So kind of like with Russian dolls, they're all inside of each other. We're going to start with looking at the inside part first. So if we're just considering the inverse sine of, well, let's do what we would normally do. Pretend I just started this problem. So here I've got my outermost function for this guy is going to be that cubed, right? And then I've got my innermost guy is going to be that arcsine of 5x squared. And the second one is where it's going to get complicated. So we've got the derivative of this we can do now. So I've got 3 g of x squared, right? And g of x is that inverse sine of 5x squared squared. All right, so we're good with that piece. Now when we look at the derivative of g, we've got an inside and an outside function again. So rather than use f and g again, I'm just going to switch to a different notation. So let's use, I don't know, h and k, I guess. So I'm just going to write here, we have to do the chain rule again. So my outside function is the inverse sine. My inside function is that 5x squared. If you want to do this again with f and g, that's fine. I just think that might get confusing for some of you. So I'm trying to avoid that confusion right now. And then we have our inside function, that 5x squared. The derivative of the inside function is pretty fast. It's just bring down your 2. 2 times 5 is 10. Make the exponent 1 smaller. It's going to be 1, so it's just 10x. The derivative of h with the inside staying the same. Our derivative of arcsine is 1 over square root 1 minus the input squared, so minus k of x squared. So I've got 1 over 1 minus k of x is 5x squared, squared, 1 over square root 1 minus 25x to the 4th. All right, so we are now going to have the derivative of g. That's what we just found, what we found here using the chain rule again. So the derivative of g we get by doing the chain rule our second time, which is going to be when we do our h prime k of x times k prime. So I've got 1 over square root 1 minus 25x to the 4th times 10x. So our derivative of g, our original inside, is 10x over the square root of 1 minus 25x to the 4th. All right, so we're at a point now where we have the stuff we need to have finished our chain rule the first time. So now that we have that, the derivative of f with the inside g of x staying the same, and the derivative of g, these first two here, we can finish our derivative of the function. So our function was, oh geez, am I going to remember? Inverse sine 5x squared to the 3rd. Our dy dx, we're taking that derivative we just found and the derivative with the inside staying the same, doing the product. So I've got 3 sine inverse sine -1 5x squared times 10x divided by square root of 1 minus 25x to the 4th. So that's going to be 30x inverse sine 5x squared divided by the square root of 1 minus 25x to the 4th. So that's definitely by far the hardest problem on this, because you have to apply the chain rule twice. So we amped it up a little bit with this one, but hopefully after you finish this we do, you're feeling confident enough to take a stab at the next set of problems that I do.